For decades, Toyota built its reputation on quiet strength, the dependable force behind millions of drivers worldwide, never needing to shout to be heard. But something shifted. In a rare, pointed statement, Toyota's CEO stepped into the spotlight with a message few expected. Our new dynamic force engine will destroy the competition. It was more than a challenge. It was a signal that Toyota was no longer content staying in the background. So, what exactly is this engine? And why is Toyota so confident it will leave everyone else behind? Let's uncover the real story behind Toyota's boldest move yet. Toyota is not just improving its engines, it's changing how they work to meet future needs. With its new Dynamic Force engine series, Toyota is focusing on improving fuel engines. And while many other companies are switching completely to electric vehicles, these engines are not small updates. They are part of a long-term plan connected to Toyota's global design system, called TNGA, or Toyota New Global Architecture. This system helps Toyota build cars that are stronger, more efficient, and easier to produce. And while many companies are focusing only on electric cars, Toyota is improving both fuel and electric systems. The CEO of Toyota said that the new Dynamic Force engines are a big part of the company's plan. These engines are designed to use less fuel, create fewer emissions, and still deliver strong performance. They can also work with different types of fuel, such as ethanol or hydrogen. Toyota believes that fuel engines can still improve and play an important role in the future of transportation. This choice is based on global needs. In many countries, electric cars are not practical because charging stations are limited and electricity is not always reliable. In those places, efficient fuel engines are still the best option. Toyota is building engines that can work in these areas while also meeting environmental rules and keeping costs low. The new Dynamic Force engines are designed to work with Toyota's TNGA platform. TNGA is a system that allows different cars to share the same parts and design, which helps reduce production time and makes it easier to use the same engine in many types of vehicles. For example, the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes, like switching to new types of fuel. The Dynamic Force engines focus on more than just speed or power. They're built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency, meaning the engine can turn more fuel into usable energy rather than losing it as heat. These engines also use a longer piston stroke and a mix of fuel injection methods to improve performance and reduce emissions. Cooling systems are also more advanced, with electric water pumps and better temperature control helping the engine stay at the right temperature. This makes the engine last longer and work better in different weather conditions. Every part of the engine was designed with care to support both performance and fuel savings. The Dynamic Force series includes 3 types of engines: a 3-cylinder, a 4-cylinder, and a V6. The i3 is small and uses less fuel, which is good for compact cars. The i4 is the most common type, found in many mid-size cars. The V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production, so the same engine can be made in different countries with local parts. This saves time and money while keeping quality high. It also helps Toyota deal with supply issues or changing demand in different regions. Because these engines follow the TNGA system, Toyota can quickly adjust production based on local needs. For example, if one market needs more ethanol-based engines, Toyota can shift resources without major changes. This kind of flexibility is useful in today's fast-changing industry. Why does this help Toyota compete? The Dynamic Force engines give Toyota an advantage. While other companies are moving away from fuel engines, Toyota is improving them to meet both current and future needs. These engines are ready for multiple types of energy and work well with hybrid systems. The Dynamic Force engines are designed to fit perfectly within the TNGA layout. This means engineers don't have to redesign the car every time they improve the engine. This helps Toyota stay ahead in markets where clean energy is growing quickly. By building flexible cars that support different powertrains, Toyota can adjust its lineup without big design changes. This is a major advantage in today's auto industry, where energy systems are changing fast. Several cars built with TNGA and dynamic force engines are already on the road. Models like the Toyota Corolla, Camry, and RAV4 use this setup, and they have seen improvements in both performance and efficiency. Drivers notice better fuel economy, quicker response, and smoother driving. For Toyota, these results show that the TNGA system works as planned. It supports fast changes, reduces production time, and helps introduce new engine technologies across many models. This gives the company a strong position in both traditional and emerging markets. Every major leap in automotive progress begins with the engine. For Toyota, the dynamic force engine represents the next stage in internal combustion design. These engines are not simply a tweak of the past, they are a complete redesign of how power, efficiency, and emissions are balanced. Developed from scratch and built to pair with Toyota's TNGA platform, the dynamic force family brings a focus on thermal efficiency, smart air-fuel management, high-speed combustion, and mechanical precision. Toyota's engineers embarked on a mission that the broader automotive engineering community had long considered an exceptionally difficult, if not nearly impossible, challenge, significantly increasing the thermal efficiency of a conventional gasoline engine to achieve levels that had historically been the exclusive domain of more complex hybrid systems or highly efficient diesel powertrains. In the realm of internal combustion engines, thermal efficiency is the critical metric that refers to the percentage of a fuel's inherent chemical energy that is successfully converted into useful mechanical work as opposed to being lost as waste heat through the exhaust or cooling systems. Traditional, well-developed gasoline engines have typically plateaued with thermal efficiency in the modest range of just 30–33%. Meaning the vast majority of the energy from each drop of fuel was being squandered. The revolutionary dynamic force engines audaciously break past this long-standing thermodynamic barrier, with documented figures now reaching a remarkable 40% in standalone gasoline-only configurations and climbing even higher to an unprecedented 41% when integrated into hybrid setups, effectively closing the efficiency gap with other powertrain types. This monumental improvement does not stem from a single silver bullet, but from a deeply integrated and synergistic combination of advanced technologies, all working in perfect harmony. Instead of focusing on enhancing just one isolated system, Toyota's holistic approach involved a fundamental re-examination of how every single component and phase of the combustion process could be radically enhanced. This comprehensive optimization includes the precise high-pressure delivery and atomization of fuel for a more complete burn, the intelligent management of airflows into the cylinder with high swirl and tumble ports for optimal mixing, the innovative reshaping of the combustion chamber to support ultra-lean burn and high compression ratios, and the meticulous management of heat during ignition to minimize losses. The concerted and simultaneous improvement across all these interconnected areas, a testament to systems-level engineering, is